Hello everyone, welcome to the solution of LeetCode problem 52 named n queens 2. In this problem, we are given an integer n and we have to return the number of distinct solutions to the n queen puzzles. The n queen problem is we are given an chessboard of dimension n by n. We have to place 4 queens in this chessboard such that no 2 queens can attack each other. Let's analyze the first example. Here, at first, the n is 4. That means the size of our chessboard is 4 by 4. Now, if we place our first coin into the second position of row 1, we should not place any other coin into the same row, into the same column, into the same positive diagonal, and into the same negative diagonal as well. Because a queen can attack each other if they are placed in same row, same column, same positive diagonal, or same negative diagonal as well. So in the first example, at first, suppose we put our first coin into the second position of row 1. Then we have to put our second coin in the fourth position of row 2. Because by doing so, both of the first and second coin will not attack each other. For the third coin, we have to place it into the first position of the third row. And for the fourth coin, we have to place in the third position of the fourth row. And by placing all of the 4 queen in 4 different locations, all of them cannot attack each other. So it is one possible solution. There is another alternative solution, which is if we put the first coin in the third position of the row 1, then we have to put the second coin into the first position of row 2, and we have to put the third coin into the last position of row 3, and we have to put the third coin into the second position of row 4. And by doing so, none of the coin will not attack each other. So we can say that for n is equal to 4, there are 2 distinct solutions. I hope you understood the problem. Now the constraints are the value of n can be in between 1 to 9. I hope you understood the problem. Now let's move on to the working procedure of this solution. Anyways, I am explaining the working procedure of this placement of the queen graphically in the next section. At first, we have to understand the working procedure of the queen placement. If we place any queen in a cell, then we cannot place any other queen in the same row, in the same column, in the same positive diagonal, and in the same negative diagonal as well. So we can say that a queen can attack the cell if the cell presented in the same row, in the same column, in the same positive diagonal. I am considering this as the positive diagonal because the slope of this diagonal is positive, and for the negative diagonal as well. So we can say that for each queen, we have to check 4 conditions. If we place any queen in a cell, we cannot place any other queen in the same row, in the same column, in the same positive diagonal, and as well as in the same negative diagonal as well. Now, at first, if we place our first queen into this position, we have to place our second queen in the second row because it doesn't make any sense if we place the second queen into the same row as well, because in this case, they will attack each other. Now, we have to check 4 conditions to place the second queen. At first, we have to ensure we should not place the queen into the same row. So, for this, we have to recursively call the callback function from the next row. And for the second condition, we have to check we should not place the second queen into the same column. So we have to place the second queen into the next column. By using this, we can ensure the first 2 conditions. Now, in the third condition, we have to ensure that we should not place any queen into the positive diagonal. So in this case, we have to check the positive diagonals as well. So how can we do that? There is a simple way to check the positive diagonal. Suppose this is our positive diagonal. And for this positive diagonal, we have to check the value of row plus column. Now, for this position, the value of row plus column is 3 plus 0, which is 3. For this position, the value of row plus column is 2 plus 1 is equal to 3. Now, for this, the row plus column is 1 plus 2 is equal to 3. And for this, the row plus column is 0 plus 3 is equal to 3. And for the clarity, we have to check one more positive diagonal. Here, for this, the row plus column is 3 plus 1 is equal to 4. For this, the row plus column is 2 plus 2 is equal to 4. And for this, the row plus column is 1 plus 3 is equal to 4. So we can say that all the value presented in the positive diagonal, which is row plus column, is same for each of the diagonal. So for a queen, we should not place any other queen in the cell for which the r plus c is equal to 3 or 4. So by using the value r plus c, we can find all of the positive diagonals. Anyways, let's see how can we find the negative diagonal as well. Suppose the negative diagonals are this. Because the slope of this diagonal is negative, so we can consider it as a negative diagonal. Now, for the negative diagonal, we have to check the value of row minus column. For the first cell, the row minus column is 0 minus 0, which is 0. For this, the row minus column is 1 minus 1 is equal to 0. For this, the row minus column is 2 minus 2 is equal to 0. For this, row minus column is 3 minus 3 is equal to 0. Again, for this cell, row minus column is 0 minus 1 is equal to minus 1. For this, the row minus column is 1 minus 2 is equal to minus 1. For this, the row minus column is 2 minus 3 is equal to minus 1. Again, for this diagonal, the row minus column for this value is 0 minus 2, which is minus 2. And for this, the row minus column is 1 minus 3, which is minus 2. So we clearly see that for each negative diagonal, the values of row minus column are same. So we should not place our second queen in any cell where the value of r minus c is exactly equal to the value of r minus c of the first queen. So by ensuring this logic, we can eliminate the negative diagonals as well. So finally, we can say that at first, we should not place our queen into the same row, and we will check this condition by using the row number. Secondly, we should not place our second queen into the same column. For this, we will check the column number. Thirdly, we should not place our queen into the same diagonal or into the same positive diagonal. For this, we have to check the value of r plus c or the row plus column. And for the fourth condition, we should not place our queen into the same negative diagonal as well. And for this, we have to check the value of row minus column. Now, let's try to put all of the 4 queen into the chessboard by using this 4 condition. Suppose at first we place our queen into the second cell of the first row here. So for this queen, we cannot put any other queen in this position, this position, this position, this position, and so on. So we can say that for the first queen, all of this marked position is prohibited for the next queen. So we have to place the next queen into the second row. So we can place it here, because by placing the second queen here, both of the first and second queen will not attack each other. And again, for the second queen, we cannot place any other queen in this position as well, and in this position as well. Now, we can place the third queen into the third row here. If we place the third queen here, these three queens cannot attack each other, but we have to prohibit this cell for the next queen. Because if we put any queen here, this will attack each other. Now, for the fourth queen, we have remaining only one place, which is this. And by placing the fourth queen here, all of these four queens cannot attack each other. So this is a one possible formation. And there is also another possible formation which is mentioned in the question. So anyways, I hope you understood what is the working procedure of this program. Now let's explore the decision tree. Suppose at first we are presented in the first row. For the first row, we have four choices. Either I can place in the first position, in the second position, in the third position, or in the fourth position as well. Now, for each of the position, we have another four choice. So I am not exploring the entire decision tree right now. I hope you understood the working procedure of the decision tree and also the mechanism of placement of the queen into the chessboard and the mechanism in which we are checking four conditions before placing a queen. I hope you understood the algorithm. Now let's move on to the code. In this code, at first, we are given a function named total n queens. The parameter of this function is n, and we have to declare a vector to store the answer. At first, we have to fill our chessboard with empty cell, which is dot. Then we have to recursively call one backtracking function. The first parameter of this backtracking function is n, which is the given parameter. The second parameter of this function is 0, which is the starting row number of this backtracking function. The third parameter of this backtracking function is result, which will store the result. And the fourth parameter of this backtracking function is the default empty chessboard. Now, in the backtracking function, at first we have to check whether our current row is equal to n or not. If it is, then we have to insert our current chessboard into the result vector. Otherwise, we have to run a for loop from 0 column to n column. And in each of the for loop, we have to check a condition. But wait, before starting the backtracking call, we declared three sets. At first, our first cell will contain the value of column. The second set will contain the value of negative diagonal. And the third set will contain the value of positive diagonal. So in each iteration, we have to check either our current column is presented in the column set or row minus column is presented in the negative diagonal set or row plus column is presented in the positive diagonal set. If it is, we have to simply continue. And by checking these three conditions, we are ensuring that our current queen cannot place in the same column, same positive diagonal, and same negative diagonal of our previous queen. Now, after checking this condition, if we did not find any other value in this three set, then we have to insert our current column into the column set, current row minus column into the negative diagonal set, and current row plus column into the positive diagonal set. And we have to place our current queen into the board of row and column position. Now, we have to recursively call the backtracking function from the next row, which is row plus 1. Now, we have another choice. We can simply ignore our current position. If we ignore our current position, we can simply erase our current column, row minus column, and row plus column value from the corresponding sets and make our board position of this current row and column empty. And finally, we have to return the size of the result vector. The size of the result vector will contain all of the unique chessboards. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.